Hi guys, today we'll be learning about 2D collisions. I'll be telling you how to solve these problems from a J point of view. So let's get started. Now, see the algorithm. The first step of this algorithm is the conservation of linear momentum. Now, this has to be done along a direction where the net external impulsive force is 0. Mostly it happens that for spherical objects, this direction along which the net external impulsive force is 0 is mostly along the line normal to the line of impact. Now comes the big question. What is the line of impact? For spherical objects, yes, again, spherical objects, the line of impact is the line that joins the center of both the spherical objects. So this thing right here is our line of impact. Now, what is normal to the line of impact? You are very smart kids, you already know. This line over here is the line normal to the line of impact. And for this object, this is the line that is normal to the line of impact. Now let's see. Let us assume that this angle over here, this one, is theta. And this ball was going towards the right with a velocity, let's say small u. Now, the component of this u along the line normal to the line of impact would be u sine theta. Sine of theta. Now, since we can say that the net external impulsive force along this line is 0, so the linear momentum along this line would be conserved for this blue ball right here. So we can say that after the collision, the velocity of this blue ball along this direction would be u sine theta. And similarly for this, we can say that the velocity would remain same after collision along this direction, that is, it will remain 0 along this direction. And for this direction, we can apply the elasticity equation and we can get equation and then we can solve them. I'm so sorry, this occurs sometimes. Now there are cases when this is not applicable. It's universal if you apply this conservation thing along the line where the net external impulsive force, I'm giving emphasis on external impulsive force. Impulsive because if there is gravity given in all of these questions, you cannot take that to be an external impulsive force. Now, for this question, you see that there we have our tension. Oh, just wait. There we have tension over here. So along this line of impact, we have an impulsive force of the contact force of these balls, and along the line that is normal, we have component of tension, so we cannot apply along this direction, but we'll see what happens. You guys figure it out. I will give it the solution in the next video. Just try your brains. Now, coming over to our next step of the algorithm, this again happened. The Newton's law of collision. It says that the coefficient of elasticity is negative of the relative velocity of separation divided by the velocity of approach. The relative velocity of approach. So how do we apply this? That's the big question. Now let's say that this is our object 2 over here. This ball is the object 2, and this is our object number 1. And the ball is approaching the wall with a velocity, let's say u, and the wall as usual is stationary, and and let's say after collision the ball recedes away with a velocity, let's say v, and you would be given the coefficient of velocity in the question. So we can say, and let's assume, one thing I forgot is that let's assume that this direction to be positive, and automatically this direction would be negative. So now let's apply the elasticity equation. So Newton said that this E right here is equal to, what do you say, negative V2 is this V, which according to our sign convention is minus V, minus V minus V1, that is 0 whole divided by U2, that is U, minus 0. So this says that E is equals to V by U. So if E is given to you, U is also given to you can also find V. Now let's move on. So I've told you the algorithm, in most of the question this works. You might be liking to apply conservation of energy or something like that. Please do not. You can only apply the conservation of energy thing when there is an elastic collision, i.e. E is equals to 1. Please do not apply it in conservation of energy in where like E is less than 1, like 0.7 or something. Please do not do that. So now, since you're so brainy kids and you're preparing for JEE, it's some test time. So there are some good questions that I have for you. Just try them, and just try them. So the first question says that find the velocity of each of the balls after collision. If E is equals to 1 and the string remains stuck, both the balls are identical. Just remember that there is an impulsive force along this direction. So you have to apply the conservation of momentum in some direction where the net impulsive force is 0. Or one thing I forgot to tell you is that you can also apply it on the entire system. Let's go up and I'll tell you something. I wasn't supposed to tell you this thing, but let me tell you. See, in this case there is a tension force, right? So you cannot just apply conservation of and there is like this impulsive force in this direction. So there is like no direction where there is this direction. I mean, if you take the resultant, but that would be extremely difficult. So one thing that you can do is that don't apply this conservation thing on just the blue ball. Apply that on the entire system of this ball along this direction. Let's make it a bit more beautiful, along this direction, because you see, along this direction you have tension, and normal to this you do not have any impulsive force, so it will be better. Yes. Now let's move on. So I think you guys can do this thing. And now coming to the next question, find the velocity of the wedge and the ball after the collision if the surface beneath the wedge is smooth and the mass of the ball and wedge is m. The collision is elastic. The diagram related to is this. Now let's move on to the next question. This is a good one. A ball of mass m strikes a wall with the initial velocity of this and rebounds with a velocity this. Find E. So guys, this is your homework. Just try these and tell the answers in the comment section, and I'll be releasing a video next week in which I'll be giving you the solution of these 3 questions, and just try them. These are very good questions. Thank you for listening me till the end, and thank you guys. Just please share this video so that new JE aspirants are benefited, and thank you so much.